We have applied rule 1 of our Playfair cipher. And so let me run this again just to see that. There you go. With the first line is our key matrix, and the second line is our plain text, which is hide the goal in the tree stump, and that has been split into diagrams, and repeated characters are split up. We've added the X for if there's a repeated character, and that happens where for the word tree, TREE, it becomes EXES, right? All right. So we are done with rule 1. Now let's apply rule 2, 3, 4 on the pairs. Right. So for pair in plain text pairs, and we have actually the ciphertext pairs, which is where we're going to store our encrypted output. Let's talk about rule 2. If the letters appear on the same row in your table, replace them with letters to their immediate right, like so. So if we have the letter EX, and then it will become XM. First thing we need to do is we need to check that the letters appear in the same row. So we'll use we'll have to actually go through every row in our key matrix. For row in I forgot what we call that, key matrix. Yeah, okay. For row in key matrix, if the first character pair of 0, pair sub 0, is in the row, and pair sub I, the second character, is also in the row, then we have met the condition to apply rule 2. Okay, and just a little bit of looking at the flow of the program. If we have applied rule 2, we will actually want to skip past rule 3 and rule 4. So then we will then, I think, need to have a state available to keep track of whether we have applied a rule or not. So applied rule starts off for every iteration of this rule will start off as false, and once we have applied our rule, over here we'll actually say applied rule will be true, and once we finish that, if we have applied the rule, we want to short circuit the rest of rules 3 and 4, we'll tell the code, right, the continue statement actually tells it to go straight up to the top of the for loop and work with the next pair. Okay, right. So now we know that for this row in the key matrix, both the first character and the second character of the pair appears there. We'll need to find the index that they appear in. Right. So let's store the first index in the variable j0. Row.find 0. Right, and because we have this conditional already, we know that we are definitely going to find that character. So I'm not gonna worry about what happens if we don't find it. We are going to get an index of find. It's going to return us -1, and what do you have to do with that? We don't have to worry about that. And so then J1 will hold on to will find the location of the second pair. Okay. So we are gonna then create our ciphertext pair. So the first character will be a row of, it will be J0 plus 1. But we want to make sure that we wrap around to the left. So if it's 5, it will go back to 0 using this remainder arithmetic, which I believe we have looked at before when we did the scissor cipher. So that's going to be a square operator, and then the second row will be k1 plus 1. The letter to its immediate right, and we wrap around if necessary, and we will append that to our ciphertext pairs list, which is empty here. We will append this over there. Okay, right? So that's rule number 2. Now we are gonna apply rule number 3 if the letters appear in the same column in your table. So it's not as easy to grab a column from our representation of the key matrix as it is to grab a row. So we are gonna, the code is gonna be a little bit more complicated. I'm also wondering, can I actually test out? Yeah, can I test it out? Let's test it out, right? So what happens is that I'm not gonna implement rule 3 or rule 4 yet. Instead, if we did not apply rule 2, we'll actually just append our pair to our ciphertext pair, and at the end of it, we are gonna print out our ciphertext pairs. Okay, let's run this and see what happens. Right, so, rather than actually append that, let's append an empty pair of characters. Okay, so we'll see that the rule 2 was applied to 2 cases, EX and TU. Let's take a look here. There you go. EX was encrypted to XM, which happened here. And then later on, we'll do it again. The pair TU is in a row. We'll replace it with UV, and we did that here. So, right, we have a high degree of confidence that our implementation of rule 2 is correct. Having done that, we are going to move on to applying rule 3. Right, so as I mentioned, it's a bit more difficult to retrieve a column from our key matrix, but we're gonna give it a go. We are gonna have to go through every single column. So we'll have the index J for going through every single column, and we are gonna build our column using list comprehension. So we're gonna pull out from the key matrix from the ith row the j character in for I in range of 5, and we're gonna join that into, that's gonna give me a list of 5 characters, and we want it to be in the same format as above, so we're gonna join that up. Okay, and then we can actually apply the same, more or less the same code. We'll need to change it a bit. Okay, so if pair of O is in column and pair of 1 is in column, then here we'll need to find the index of the respective rows, right? And so we'll change all references of row to column, and instead of J, which is I'm in my head I'm thinking of J as the vertical index and I as the horizontal index. And so yeah, so I is the row number. So I'm gonna put I0 I1. Let me think, is this right? I think so. Let's run it, and then if it doesn't work, then we'll figure out, oh no, it should be column. If it doesn't work, we're gonna figure it out. We'll find it and we'll debug it. Okay, so you can see that it was applied once to the DE pair of character. Let's just check our Wikipedia page. And actually, yeah, there is only one instance in which you have a column, and that is DE, and that is replaced by the characters OD, and we did that. Okay, so we have some degree of confidence that our rule number 3 is also implemented correctly. So the last one is rule number 4. So if rule number 2 doesn't apply and rule number 3 doesn't apply, then it will be rule number 4, where they are not in the same row and they're not in the same column. Right? They can make a rectangle. So we are actually going to, let's see, take note of their positions, right? So I'm gonna have like I0 and I1, and I'm gonna initialize it all to 0, right? We'll need to find the ith and jth position. So we'll go to every single row, and if our character is in that row, then I0 will be, oh right, no, so I won't get the index this way, so I will need to do it in this other way for I in range of 5, right? And then the row will be key matrix I. Okay, right? So if it's in the row, then the row number will be I, and then the column number will be row.find pair of 0, and we'll do that also for the second character. If we find it, then we can get the ith and j coordinates. So once we have that, once we run through this code, we'll then have the coordinates of the first letter and the coordinates of the second letter in our key matrix. Right, so then what we need to do is we need to apply the rule. So for the first encrypted letter, we are going to ciphertext pair. Let's do our ciphertext pair. For the first character, we will actually find from the key matrix, it's going to be the same row as our character, but it's going to take the column from our second character, and similarly for our second character, it's going to be the same row as our second character, but the column of our first character, right? We're going to do that mix up, and then we're going to append it to our ciphertext pairs. Okay, and because this is the last rule, it's definitely going to happen. We don't need to use the applied rule variable. We don't need to do any more bookkeeping because it's going to be reset to false in the next iteration of this for loop also. So let's run this module and take a look at the outputs. Right, we have this, and let's compare it against the work example in Wikipedia. We're supposed to get BM, yes, OD, ZB, XD, NA, BE, KUD, MUI, XM, MOU, VIF. Right, so there you go. With our plain text, hide the goal in the twist stump, it's going to become BM, OD, ZB, XD, and so on and so forth. Let's actually print that out nicely. We're going to join it. Okay, let's print it out nicely. And we'll see. Right, so for our plain text, hide the goal in the twist stump, this will be the cipher text that we get from it. So this is the encoding using the Playfair Cipher